We now discuss the solution of the problem from the section three-dimensional geometry. The problem is on the given two lines and a plane. This question has appeared in the joint entrance examination main held on 26th June 2022 in the second shift. The given question is, if the lines r is equal to I minus j plus k plus lambda times 3j minus k, and the second line r is equal to alpha I minus j plus mu times 2i minus 3k are coplanar, then the distance of the plane containing these two lines from the point alpha, 0, 0 is, we are given four options. Option A 2 by 9, option B 2 by 11, option C 4 by 11, option D 2. Now, we are given two lines in a vectorial notation, and the first line is this one and the second line is this one, in which there is a scalar alpha which is to be determined, and they are given. These two lines are coplanar, that means they lie in a plane. Then we have to find the distance of the plane containing these two lines. The distance of the plane containing these two lines from the point alpha, 0, 0 is. That is the given question to us. We now discuss the solution of the problem in detail. We have two lines which are given in a vectorial notation, and the first line we call it as L1 and the second line we call it as L2. L1 is given by R is equal to I minus j plus k plus lambda times 3j minus k. What is this line? This line is passing through the point 1, minus 1, 1 and parallel to this vector 3j minus k, and L2 is equal to, L2 is given by R is equal to alpha I minus j plus mu times 2i minus 3k. Right. It is given that L1 and L2 are coplanar. Let's recall the condition for coplanarity. Two lines R is equal to A plus lambda b and R is equal to C plus mu d are coplanar if C minus A, the vector C minus A dot B cross D is equal to 0. So in our case, L1 is R is equal to A, this is A plus lambda B, and L2 is R is equal to C plus mu times D, and they are coplanar if C minus A dot B cross D is equal to 0. C minus A, C is alpha I minus j minus A is minus in brackets I minus j plus k bracket close dot B, that is 3j minus k cross D, that is 2i minus 3k. So that means this implies j minus j plus j cancels, and this vector will be alpha minus 1 times I minus k dot 3j minus k cross 2i minus 3k is equal to 0. And this is what we see is the scalar triple product of three vectors, and that is also called as the box product, and it is given by in the determinant notation. This is equal to the determinant of alpha minus 1, the component of j is 0 minus 1, and the second row is the components of 3j minus k, that is 0, 3 minus 1. Third row 2, 0 minus 3 is equal to 0. Let us now expand this determinant by the first row. So that's the expansion. Simplify. Then we will get the answer for alpha as 5 by 3. So the alpha is unknown here, and thus we got the value of alpha using the coplanarity. Agreed. We continue in the next slide. That's what we have done so far, and we have found the value of alpha as 5 by 3. Let P be the plane containing the lines L1 and L2. So look at the demonstration. This is the plane P. This is the L1. This is L2. That means P is the plane containing the lines L1 and L2. And look at L1. L1 is passing through 1 minus 1 plus k. So on L1 there is a point 1 minus 1 plus 1. Notice that L1 passes through the point 1 minus 1, 1. Look at that. So this is the point on L1. Agreed. Because P is the plane containing these two lines, and this point lies on L1, therefore the plane P passes through this point 1, minus 1, 1. Now we will now find the normal to this plane. Normal to the plane P containing these L1 and L2. Notice that the normal n of the plane P is given by n is here. So that is the normal, and is given by n is equal to a L1. No, this is a plus lambda b, that is b cross d. That is 3j minus k cross 2i minus 3k. So if you do that, then you will get the normal. And that is determinant ijk 0, 3 minus 1, 2, 0 minus 3. Expand by first row and obtain the answer as minus 9i minus 2j minus 6k. So in this, minus 9, minus 2, minus 6 are the direction ratios of this normal. We continue in the next slide. Right, we have alpha, and P passes through 1, minus 1, 1, and the normal to the plane is minus 9i minus 2j minus 6k. So now we write down the equation of the plane. The equation of the plane is it passing through 1, minus 1, 1. That means x minus 1, y plus 1, z minus 1. That dot with this n. That is the equation of the plane P is x minus 1 into minus 9 into y plus 1 into minus 2, z minus 1 into minus 6. This is a very standard formula what we have used. Right. Now cancel throughout by minus and multiply and write down and simplify. We'll get the equation of the plane P is 9x plus 2y plus 6z minus 13 is equal to 0. Now what is that we want now? We want the distance of this plane P from the point alpha, 0, 0, where alpha is 5 by 3, 0, 0. So the distance formula. So the distance of the point from the plane, the formula we will write mod of 9 into 5 by 3 plus 2 into 0 plus 6 into 0 minus 13 by under the square root of the square of the coefficient of x, that is 9 square, plus the square of the coefficient of y, that is 2 square, plus the square of the coefficient of z, that is 6 square. So under the square root of 9 square plus 2 square plus 6 square is under the square root of 121, that is 11. And when you simplify the numerator, you will get 15 minus 13 modulus. And that will be 2 by 11. That is the required answer for this question. Let's look at our options. Our answer 2 by 11 appears against option B. Therefore, the answer to this question is option B. So that is the detailed discussion of the solution of the problem on two lines and a plane from the section three-dimensional geometry. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.